I recently had a conversation with an anti-earther by the name of Bob the Science Guy, wherein he asked me where the educational system had failed me. My answer is in this book right here. This book has failed me miserably. Bob also encouraged me to go read a book or watch a video about astronomy. Thank you for the encouragement, Bob. That is exactly what we are doing today. As many can attest, when you join the Censored Earth community, you are given a new set of eyes. Now, I've studied Earth science before, but now that I've been given a new set of eyes, I'm going to go back and take another look and tell you what I see. This is modern Earth science destroyed. Birth of a theory. The Big Bang.
Scientific methods are useful tools for the study of Earth science. However, the development and testing of a hypothesis is just one step along the way to scientific understanding. Once a hypothesis has been tested and generally accepted, it may lead to the development of a theory. A theory is a hypothesis or a set of hypotheses that is supported by the results of experimentation and observation. A theory provides a general explanation for scientific observations that is consistent with known facts. Once a theory is well established through research and experimentation, it may become a scientific law. A scientific law is a rule that correctly describes a natural phenomenon. To become a law, a theory must be proven correct every time it is tested. For example, the law of conservation of mass and energy, which states that the total amount of matter and energy in the universe does not change, has been tested again and again. It has never been found to fail.
The total amount of mass and energy in the universe doesn't change? They speak as though they knew exactly how much energy and mass was in the entire universe, as if someone had gone out and explored it all.
I'd go to the moon in a nanosecond. The problem is we don't have the technology to do that anymore. We used to, but we destroyed that technology, and it's a painful process to build it back again.
This book makes it sound like they went a lot farther than the moon.
They must have destroyed a lot of technology there. How can they claim to know the total amount of mass and energy in the entire universe if we don't even know how much mass and energy is at the bottom of our own ocean?
Yeah, it seems they didn't count all the mass and energy and all those new fish people are continually finding, let alone all the new stars people are continually discovering.
Light and the Doppler effect.
Observations made more than 300 years ago still provide us with the tools to study the formation of the universe. In 1665, the British scientist Isaac Newton observed that sunlight passing through a glass prism produced a rainbow of colors: red, orange, yellow, green, blue, and violet. Newton named this display of colors the spectrum. Light travels in waves. The distance from the crest of one wave to the crest of the next is the wavelength. Each color in the spectrum has a different wavelength. Red light has the longest wavelength, and violet light has the shortest. As light passes through a prism, each wavelength is bent at a different angle, and the band of colors results. In the late 19th century, research revealed that when chemical elements are heated, they too produce spectra. An element is a substance that has a characteristic set of physical and chemical properties. Instead of a full spectrum of continuous colors like that produced by sunlight, a heated element produces only a series of thin colored lines spaced at uneven intervals. This series of colored lines, called a bright line spectrum, indicates that the light source is sending out only certain wavelengths of light. Each element produced its own bright line spectrum, as unique as a set of fingerprints.
So here they are showing us different color patterns that these elements produce. I just really wish the book explained what each of those numbers at the bottom of the illustration represent. My best guess on the matter is that they are just showing us the range of the color spectrum. If each color were to be assigned a number, that would be it. Let's continue though.
Scientists also discovered that when a light source is moving toward an observer, the wavelengths of the light produced appear shorter to the observer.
Ah! They're saying scientists discovered again. What scientists are they talking about? Let's do the book one better here. According to Space.com, Edwin Hubble was the first to describe the redshift theory. See, that wasn't so hard.
We could try and continue to do that and do our best to insert names every time they vaguely use the term scientists. But they are supposed to be the educators here. It isn't our burden to go out and prove all their claims. They are the ones trying to persuade us. The burden of proof is on them. How about we do this? From now on, unless they actually provide a name, instead of vaguely saying the word scientist, let's just say someone or some people.
If anyone would like to do a fill-in-the-blank project and try and defend the book's claims, our debate board is open, and we would love to see what you have to say.
Oh great, this is our freebie. Edwin Hubble and others also discovered when a light source is moving towards an observer, the wavelengths of the light produced appear shorter to the observer. As a result, the spectral lines of the light source appear to shift slightly toward the shorter wavelengths, or the blue end of the spectrum. When the light source is moving away from an observer, the light waves appear longer to the observer. The spectral lines of the light source appear to shift toward the longer wavelengths, or the red end of the spectrum. The faster a light source is moving, the greater the shift of its spectrum. The apparent shift in the wavelengths of energy emitted by an energy source moving away from or toward an observer is called the Doppler effect.
Light moves way faster than it is possible for any of us to move. I wonder what they are using to perform their tests. I would love to see some observations verifying their claims here. Evidence. Redshift.
Using an instrument called a spectroscope, some people studied the starlight to determine what elements were present in the stars.
What? Okay, hold on. They are saying because certain stars produce certain colors, we can determine what they're made of? Well, let's take a look at iron. In a cool state, it looks like a blackish gray, but it is also kind of reflective too. Please keep in mind here how as iron increases in temperature, it also changes in color. So if elements are able to produce a range of colors, we can't just say, oh look, this star is producing this color, therefore we know it's made of this element. Especially when we know mixing different elements can produce different colors. Here's a video I took of a star. No, I don't claim the star is in focus or anything, but that isn't the point. Whether it is or isn't focused shouldn't affect the colors we see here. Please notice how the colors are continually changing. If the colors are constantly changing, does that mean what it is made of is constantly changing? I can't say for sure, but I can say this observation certainly seems to throw a pickle into the claims this book is making.
A spectroscope contains a prism which splits starlight into a spectrum of different colors and wavelengths. By comparing the spectrum produced by each star with the spectra of known elements, some people were able to determine the chemical makeup of various stars. The Sun, for example, was found to be about 92% hydrogen and almost 8% helium, with traces of nearly 100 other elements.
Those are some pretty hefty claims. Hefty claims require hefty evidence, and I'm not seeing any.
Yeah, this is pretty disappointing. The study of starlight spectra revealed surprising information about our universe. Some people found that the spectra of most galaxies, or large system of stars, tested were shifted toward the red end of the spectrum. Only a few close galaxies showed a shift toward the blue end of the spectrum. The red shift indicates that almost all of the galaxies in the universe are moving away from the Earth. By examining the degree of redshift, scientists were also able to, some people were also able to determine the speed at which the galaxies were traveling. Some people found that the most distant galaxies showed the greatest redshift and thus were moving away the fastest. From these observations of spectra, most people have concluded that the universe is expanding.
Ah, so now they are saying the color of the stars can tell us the speed of the star and the direction it is moving. I wonder if the stars are different colors in the beginning of the night than they are at the end of the night. I think that would prove something.
That would be really interesting to see.
Another issue I've got to wonder about here is the filtration factor. If a star is behind a bunch of blue gas, won't that tint the light from the star and throw off what people think it's made of?
Yeah, it totally should.
A theory emerges.
Observations of redshift led some people to propose a hypothesis to explain the expanding universe. The hypothesis states that billions of years ago, all the matter and energy in the universe was compressed into an extremely small volume. About 15 billion years ago, a sudden event called the Big Bang sent all the matter and energy hurtling outward into a giant cloud.
About 15 billion years ago? Yep, they speak as if they were God and witnessed all of it. I sure don't see any other explanations mentioned as to where that number came from.
As the cloud expanded, some of the matter gathered into clumps that evolved into galaxies. Today, the universe is still expanding, and the galaxies continue to move apart from one another. This movement causes the apparent redshift in the spectra of galaxies.
Yet, the constellations have remained constant enough that people have been able to depend on them in navigation for thousands of years.
Despite the evidence of redshift in the spectra of galaxies, a number of some people did not accept the Big Bang hypothesis. They argued that if the Big Bang had taken place as a hypothesis proposed, the energy left from the explosion would be found evenly distributed throughout the expanding universe. If this energy could not be found, they insisted then there was little reason to accept the Big Bang hypothesis. An important discovery in the 1960s finally convinced most people who had doubted the evidence of redshift. Using radio telescopes, researchers detected low levels of energy, called background radiation, evenly distributed throughout the universe.
For such an important discovery, it's disappointing they didn't mention a single person who discovered it.
The presence of this energy convinced most people that the Big Bang hypothesis was correct. Because of the abundant evidence and widespread acceptance of the Big Bang hypothesis, this explanation of the origin of the universe became known as the Big Bang theory.
Widespread acceptance. In other words, it became known as a theory because it was popular.
Like any theory, the Big Bang theory must continue to be tested against each new discovery about the universe. As new information about our universe emerges, the Big Bang theory may be revised or a new theory may take its place.
If there is so much evidence for it, it should be easy to provide some observations for us to see. But unfortunately, they didn't do that. They just expected all of us to commit the genetic fallacy and take their word for it. Public education needs to be better than this.
Hey, look at that! We're all done with Chapter 1. Chapter 2 is entitled Earth in Space. That should be fun.
Thank you for watching.